Today's lab then is testing Archimedes' principle. We want to see firsthand if Archimedes' principle is correct. So the beginning here goes through all of the ideas we've just been talking about. Notice I list the density of water is 1 gram per centimeter cubed, which is the same as 1 gram per milliliter. You're going to be measuring the volumes displaced in milliliters. So converting from volume displaced to mass displaced, how do you do that? You multiply by 1 gram per milliliter. So it's just multiplied by 1. It's a very simple process. What we're going to be doing is checking to see if the buoyant force is equal to the weight of the displaced fluid. So this equation I put in the box is the one equation you're going to use. So what you're going to do is you're going to, 1, measure weight in air. 2, measure weight in water. How are those going to help me? Well, if you're in air, if you look at the forces acting on this in air, you have the force the scale is providing, the force gravity, sum of the forces equals 0 because it's in equilibrium. So force scale minus force gravity equals 0. Therefore, force scale equals force of gravity. That's what you get for air. Now, if you do it in water, if it's submerged under the water, then you have another force. You still have the force of gravity. You have the force of the scale prime, and you have the force buoyant. So again, applying Newton's second law, don't need equals 0 twice or equals twice. Force S prime is equal to, or force S prime plus force buoyant minus force gravity equals 0. So if I want to calculate the force buoyant, I'll substitute this right here. The buoyant force is the difference in the force of the scale in air minus the force of the scale in water. Why? Because the water is lifting up, so the scale doesn't have to lift up as much. So those two measurements are going to tell us what the buoyant force is simply by taking the difference. Then we're going to measure the volume displaced. So measurements 1 and 2 were the force. Measurements 3 and 4 measuring the initial and final volumes of water. So very simply, you initially had the volume here, and then you have your object in here, and the water level, water level's up there. So this change in height times the area gives you the change in volume. You're just measuring directly the change in volume. And that's how you're calculating the volume displaced. Those are both very, very quick. You measure the difference in volume, boom, volume displaced. You measure the difference in the weight, boom, you have the buoyant force. And then you just compare the two. Now, something that's probably a little confusing is the units. So for the units, we are going to calibrate our force sensors to read the weight divided by G. Now, you might recall this is something that I feel very earnestly about, that mass is not the same as force. But you can have a scale that reads in kilograms because it's calibrated to read weight divided by G. And so that's what we're going to do. So if you go to your Pasco, and you should now have a version for the 850 interfaces. Remember, if you're using the 750, open the 751. If you're using the 850, the 851. Yes, ma'am?
For us, the file doesn't even appear.
It still doesn't.
It still doesn't.
It should now because I put it there. Yeah, it should now. I will come and deal with that after I finish talking. So we need to calibrate the force sensor. So you go to calibration. Notice it's selected force sensor because it's our only sensor. Go to next. And we want the two standards, which is the one that's automatically selected. Go to next. Standard value for the first one, 0. Now comes where we have to be a little bit careful. I put it like this so the force sensor is hanging down and doing nothing. There's a button on here that says 0. So while it's in this position, so you should have yours mounted, I press the 0 button. It should have changed up there. What does it say now? Instead of minus 20, it says basically 0, right? And now I click next. For the next one, I know it says newtons, but we're going to do it for grams. So I'm going to take 50 grams. Don't hit the 0 again after you put it on here. Hang the 50 grams from there. And then I hit next and hit finish. Now it's calibrated, so it's going to read, it'll say newtons, but it's actually reading grams. So now that I have this calibrated, I'll just close the calibration tab. You have a display, let's hit start, a display that shows mass in grams over here, and then a graph. So I pull on it, you see how it changes. You can test your calibration. I'll put the 100 on here. And, okay, that must be 200. Yep, that's 200. And so you can, check and see how it works. I have it both the graph form and the number form just so you can do whichever makes you happy. There is, especially in the black ones, a fair amount of drift over time. So before an experiment, when there's nothing hanging on it, go ahead and hit that 0, or it says tear on the button if it's on the black ones, just to avoid the drift. It will stay with the right calibration. So that's how you calibrate the sensor. You're then going to use the sensor to measure the force. So after you have teared it, you're going to have string. The string is here. By now you've all learned. You can just snap the string off. Tie a piece of string around this hook. Hang your object from the string such that it will be low enough to be submerged in the water. Measure the force using your computer like I just showed you beforehand. Make sure you write that number down. Remember, you need to have an uncertainty with that. Look at how much the number is varying to get that uncertainty. You'll want to fill this with water, not all the way to the top. Try not to make a mess with the water. Make sure you have it sitting so the water's still. Measure the volume initial, record that. Once again, you have to estimate your uncertainty in how you measure. Then you just raise up the object, put it here, put it down so the object is submerged. You measure the force again, measure the volume again, you have all your measurements. Question?
We don't need to calibrate it with a stick, do we?
No. After you've made those measurements, Then you're going to do your calculation for what was the volume displaced and what was the buoyant force. You made a direct measurement of the buoyant force, right? The difference of the two. Direct measure of the volume and displaced, and then calculate, are the two equal? Be aware of your units, be careful with the units. If you choose to have 3 people in your group, each person needs to have a different object. And by different object, I mean a different type of material. So many of these have stamped on them what they are. This one does not. But you can usually tell what they are. So for instance, if we're in the same group, we're going to make sure that we don't have 2 people with just different shapes for the same type of metal. Make sure everyone has a sinker, not a floater. You can use the floaters for your test, but otherwise I want things to be sinkers. Just for your giggles here, if it says SN on it, what is it? 10, right. This one says AL, so it's aluminum. This one says ZN. Some of them, like this one here that's SN10, you'll have to be creative in how you're going to stick something on there because the screw thing has come out. Don't take the screw out of another one. I think my best bet would be to try to get a nail and jam it in there. This one here, I believe is lead. Why do I believe it's lead? Because it's soft enough that I can cut it with my fingernail. Can't cut either of any of these others with my fingernail. This one here, I believe is copper. Yeah, it says C for copper. So make sure each person in your group has a different sinking object. You will have to share from one group to another. So, you might have, Irving has an object, and when he's done, he gives it to Erica. So, because we don't have 26 objects. So each person in the group does their own object. Make sure you record everyone in your group's data. Don't just record yours. Your results will be the density that you found for your object and what it should have been. Make sure you cite your source for what the density of that material is and percent error difference between the two. Then go through your test procedure to test Archimedes' principle based on the methods we have here.